Okay, let's do a substitution differential equation. Now, I will say I do not like these. You kind of have to have a knack for picking out patterns, and you also have to have a knack for figuring out that you can manipulate a differential equation to get to a pattern. And this is one of those kind of cranky ones. So, right off the bat, you may recognize that they're kind of similar on both sides of the equation. So what you want to do in this case is actually divide everything by x twice. So let's just do it the first time, just to get rid of that. Okay, let's divide again. So when you divide again over here, you're going to get 1, because x divided by x is 1, plus y over x. And over here, you would just get x, let's see, is it x squared? Oh, no, I see, okay. I'm just going to do two steps in one. I'm going to factor out. See, here's the pattern. You have to recognize it. You're going to have y over x in various places. So let the other side help you out. And once again, x divided by x, 1 minus y over x. Okay, so now what you want to do is just go off on the side, kind of like a regular U substitution setup, and say let's say v equal y over x, and therefore y equals vx. So, in order to get this right here, take the derivative. So dy dx equals, let's see, the first times the derivative of the second, 1, so plus the second times the derivative of the first. Well, since this is in respect to x, it's dv dx. Okay, now substitute everything back in, and hopefully it will look a little better. So we have, let's just say sub in. Let's see, so we've got 1 plus v times that big old quantity over there, minus v. Okay, that does look a little bit better. And now, when you get to this point, you can start thinking along a few different methods of solving the equation. Usually, it breaks down into a separation, but sometimes, I think I saw one or two of them that you can actually use an integrating factor for. Either way, just be on the lookout, but see if you can separate it, and it does, in fact, look like in this one we can separate it. So, let's go ahead and divide this, so we get it on the other side. V, 1 minus v, 1 plus v. Okay. And then we're going to subtract v from both sides. Get x dv dx equals v, 1 minus v, 1 plus v, minus v, and you can rewrite the v. So let's rewrite the v to get a common denominator, and the common denominator is 1 plus v. So if you were to put 1 plus v under this, you would also have to multiply by 1 plus v. So let's just, sorry, I'm going to skip a step because it's just going to get too muddled on this paper. But I'll tell you what's going on. You're going to do v times 1 plus v over 1 plus v, because then you'll have the same denominator, so you'll end up with just what's up here This is this common denominator. And then minus, this is going to be v times 1 plus v. Okay, let's multiply this ugly thing out. I already did it, so it wouldn't take up too much time on YouTube. So you can trust me on this, but when you multiply this out and then multiply that out, you get... Oh, actually, you don't... I'll just do it right now. It's actually not difficult. I thought I had the FOIL. You get v minus v squared minus v squared all over 1 plus v. So here comes the point where you'll probably have to... Well, no. Huh, I didn't have to use FOIL at all for this. Sorry, just talking to myself apparently. I'm thinking of a different problem. You can simplify that up there to negative 2v squared over 1 plus v. And then all you have to do here is get all the v's and the x's on their proper sides. So let's do that. Yeah. dv equals negative 2 over x dx. Okay, so now we got a nice little separation problem going on. So integrate both sides. This is, let's just rewrite this into 2. So 1 over v squared is v to the negative 2, and then v over v squared is just 1 over v. And this is simply negative 2, 1 over x dx. Okay, looks a lot simpler. So we end up getting v to the negative 1 over negative 1 plus ln of v equals negative 2 ln of x plus c. And I'm just going to simplify this to negative 1 over v. And then the very last thing you have to do is substitute everything back in. Back up there, v equals y over x. So 1 over y over x is simply just x over y. Y over x equals negative 2 ln plus c. Okay. Once again, I hate these problems. They're long. So if you see them on a test and you can skip problems and pick other ones, personally I would skip through these. But if you're really good at really seeing these patterns, go for it.